Hello, and welcome to Backer Breaks It Down. In today's lesson, we're going to look at slope and parallel and perpendicular lines. So let's first investigate the slope and come up with criteria for parallel and perpendicular lines. So in the graph there, lines L and M are parallel, and N is perpendicular to L and M. So let's investigate the slopes of these lines. What do you notice? What do you wonder? So let's first look at lines L and M because they told us that L and M were parallel to each other. The slope of line L is -3/5. The slope of line M is -3/5. So parallel lines have the same slope. Okay, easy enough. What about perpendicular? So n is perpendicular to L and M. So I know the slope of n is 5/3. They told me it was perpendicular to M and also L. But here these are side by side. So look, what do you notice? What do you wonder? Well, they're opposites of each other because one of them is positive and one of them is negative. And then they've been flipped, and we call those reciprocals. So the slope of perpendicular lines are opposite reciprocals, and we flip to find the recip. So to summarize, parallel lines have slopes that are the same, and the slopes of perpendicular lines are negative, aka opposite, reciprocals of one another. So finding the slope of a line from an equation, because what I'm going to do is I'm going to give you two linear equations and I'm going to ask you parallel, perpendicular, or neither. And so you need to be able to identify the slope of a line given its function equation. Now, if it's in slope-intercept form, that's pretty easy. Okay, so on the left side of the screen, we have y = 7/2 x minus 3. Well, 7/2, that's the value of m, so that's your slope. So it's really easy when it's in slope-intercept form. When it's in standard form, you want to solve for y. So that first example is a really easy one. To get y all by itself, they're merely subtracting 2x from both sides. Then they get it in slope-intercept form. So the slope is -2. The example on the right involves a little bit more work and some fractions, but really there isn't anything to fret about. You're still moving the x term to the other side. That's what they're showing you right here. And then you need to get y by itself, and to get y by itself, they're dividing by -3, and then they're just simplifying everything, writing it nicely, and so they end up with the slope is 5/3 here. It's standard form. There is some algebraic manipulation you're going to have to do in order to determine what the slope is. So here I have two examples. Find the slope of each line, then determine if the lines are parallel, perpendicular, or neither. Well, in our first set of examples, we have 2x plus 3y = 6 and 6x minus 4y = 24. Unfortunately, neither one of those is written in this slope-intercept form, so I can't easily and accurately identify what the slope is. So I'm going to have to rewrite each one of these in slope-intercept form. And so I've already done that work for us. You're welcome. All right. So I started with that first line. and I got y all by itself, and I ended up with y equals negative 2/3 x plus 2. So the slope of that first line is negative 2/3. I rewrote the second line, got y all by itself, and I got y equals 3/2 x minus 6. So my slopes are opposite reciprocals of one another, which make them perpendicular to each other. So negative 2/3, positive 3/2. They're opposite in sign, and they are reciprocals. And then remember, that's the symbol for perpendicular. In our second set of examples, the line 2x plus 5y equals -1, it's in that standard form once again, so I'm going to have to rewrite it in slope-intercept form to accurately determine the slope. The second line is, well, it's not really any specific form of a linear function. I do want to get y all by itself, but that will be easy to do. I simply need to divide everything by 10 in the second equation. And so I'd get y equals, and then negative 4 over 10 is negative 2/5 x minus 2. So that second line has a slope of negative 2/5. But that first line you're going to have to rewrite, and I thought maybe I had already saved us time and done that for you, but I guess I didn't. So the first thing I would have to do is subtract 2x from both sides. So I'll have 5y equals negative 2x minus 1, and then I have to divide everything by 5. And so I get y equals negative 2 over 5 times x minus 1/5. And so this line has a slope of negative 2 over 5 as well. So we're talking same slopes here, which makes these parallel. And that there is the relationship between the slopes of parallel and perpendicular lines. Right? So parallel lines have slopes that are the same, and perpendicular lines have slopes that are opposite reciprocals of one another. I'll see you next time on Backer Breaks It Down.